Hello class, welcome to a new video. Okay, so in the last videos we have learned about the use notation, okay, for multiple correlation, partial correlation, and we have also learned about the notations of the regression, of the partial regression coefficients, and so on. So today we are going to be learning about the equation of the plane of regression. Okay, so initially we are going to start with only three variables. That means only x1, x2 and x3. Okay, so first we will see how this equation of the plane of regression it looks like for three variables, and then after we have learned about these three variables, then we can just extend it to the case of the general case of n variables. Okay, so let's get right into it. So the equation of the plane of regression of x1 on x2 and x3, okay, is given as follows. So x1 is equal to b12.3x2 plus b13.2x3. Okay, and you keep this as equation 1. So you already know what is this b12.3. You already know what this is, and you already know what is this b13.2. These are partial regression coefficients. Okay, this one is the partial regression coefficient of x1 on x2 when x3 is fixed. And this other coefficient is the partial regression coefficient of x1 on x3 when x2 is fixed. So since these two coefficients, they are constant, they are supposed to be constant terms, so we can estimate them. So how do we determine or estimate these constants? Okay, so these two partial regression coefficients, they are to be determined by that same principle which we use for simple linear regression. So we will use this principle of least squares. Okay, so the same thing which we have used in simple linear regression, we are also going to use here for this plane of regression. Okay, so principle of least squares involves in minimizing the sum of squares due to the residuals. Okay, and what is your sum of squares? Okay, residual sum of squares, suppose we denote by s, and this will be equal to x1.23. Okay, x1.23, and this I mean the square of this. Okay, and this x1.23 is nothing but the difference x1 minus b12.3x2 minus b13.2x3 whole thing square. Okay, so you keep this as equation 2. So the principle of least squares requires us to minimize this s, and in order to minimize this, we have to differentiate it partially with respect to each partial regression coefficient. That means with respect to this and with respect to this, and then we equate it to 0, and those are called the normal equations. Okay, so let us write down the normal equations. Let us write down the normal equations. So the first normal equation is you differentiate that residual sum of squares with respect to the first regression coefficient, that means b12.3, and equate it to 0. So if you differentiate this, what you will have is minus 2 is constant, so it comes outside. Here you have x2 into x1 minus b12.3x2 minus b13.2x3, okay, equal to 0. And this minus 2 is constant, so it will go to the right hand side, it will vanish. Okay, so what you'll be left with, okay, if you simplify and distribute the summation inside the bracket, you will have summation x1 x2 then minus b12 dot 3 summation x2 square then minus b13 dot 2 summation x2 x3, and this is equal to 0. So you have obtained your first normal equation. Okay, this is your first normal equation when you differentiate with respect to b12.3. Now in the same way, you differentiate s with respect to the other regression coefficient. You differentiate with respect to b13.2 equal to 0. So this implies minus 2 summation. Here you'll have now x3. Okay, so you'll have here x1 minus b12.3 x2 minus b13.2 x3. Okay, and this is equal to 0. So if you simplify this, what will you have? This implies summation x1 x3 minus b12.3 summation x2 x3, okay, minus b13.2 summation x3 square, and this is equal to 0. Okay, now you have obtained both of the normal equations. So now after this, you keep these two equations aside. Then let us define some terms. Okay, so let us define the sigma I square to be equal to 1 by n summation xi square. Then define this covariance xi xj to be equal to 1 by n summation xi xj. Okay, and then therefore your correlation coefficient ij will be covariance xi xj divided by sigma I sigma j. Okay, and if you substitute the formulas here, you will notice that these n's, they will cancel, and you will have in the numerator only summation xi xj, and then here you will have n sigma I n sigma I sigma j. Okay, and notice here that there is no x bar, because for these variables the expectation of xi is always equal to 0. I have discussed this in the earlier videos. Okay, so remember that the mean is always equal to 0, and hence your formulas for the variance, the covariance, and the correlation will look like this. Okay, so now after defining those terms, we are going to replace those terms in the normal equations with these terms. Okay, we are going to replace in the normal equations with these terms that we have just defined. Okay, so therefore our normal equation becomes, so our first normal equation will be, okay, that summation x1 x2, so that means it will be n r12 sigma 1 sigma 2. How did I get this? Okay, the first term in that first normal equation was x1 x2, and we know that r12 is equal to summation x1 x2 divided by n into sigma 1 sigma 2. So what we are doing is we are just taking this to the left hand side, okay? Therefore we will get this to be n r12 sigma 1 sigma 2, okay? So you just have to check properly all those terms and what to replace them with. Even for summation x2 x3, I think you can understand this can be written as n r23 sigma 2 sigma 3, like that, okay? And for the square terms, okay, for the square terms like summation x2 square, this you can just simply write as n into sigma 2 square, because we know that sigma 2 square is nothing but 1 by n summation x2 square, okay? So I hope this is clear. So in this way you replace all those summation x1 x2 x2 x3 x2 square and so on from that formula, okay? And you will have your normal equations to be equal to this, okay? You will have n r12 sigma 1 sigma 2 minus b12 dot 3 n sigma 2 square minus b13 dot 2 n r23 sigma 2 sigma 3 equal to 0, okay? And your second normal equation will be what? It will be n r13 sigma 1 sigma 3 minus b12 dot 3 r23 sigma 2 sigma 3 minus b13 dot 2 sigma 3 square equal to 0, okay? So we see here that this one, that okay, you see first from the first equation we see that this n is constant, so we can cancel out this n in each term. And then we see that sigma 2 is common here, so we can cancel out sigma 2 sigma 2 sigma 2. And similarly from the second normal equation, n is common. Here I forgot to write n is common, okay? Here also I forgot to write n, okay? So n is common, so we cancel out. And then sigma 3 is common, so we cancel out from each term. And we will be left with these normal equations: r12 sigma 1 sigma 2 minus b12 dot 3 sigma 2 square minus b13 dot 2 r23 sigma 2 sigma 3 equal to 0, okay? And the other normal equation will be r13 sigma 1 sigma 3 minus b12 dot 3 sigma not sigma, this will be r23 sigma 2 sigma 3 minus b13 dot 2 sigma 3 square equal to 0, okay? So previously I said we cancel out those sigma 1 sigma 2, but then no need to cancel out, we cancel out only the n and we'll be left with this equation, okay? Both of these equations you denote as equation number 5, okay? So we are going to solve this using the determinant method, okay? We are going to represent this equation in using determinants, okay? So we have to eliminate the coefficients b12 dot 3 and b13 dot 2, Okay, so we have to compare this equation with equation 1. So you go back to equation 1 and then you compare the two equations. Okay, you go back to equation 1 and you compare the two equations. Equation 1 can be written as x1 minus b12.3x2 minus b13.2x3 equal to 0. Okay, and you have to compare this equation 1 with that previous equations just now. One r12 sigma 1 sigma 2 minus b12.3 sigma 2 square minus b13.2 r13 sigma 1 sigma 3 equal to 0. Actually this is r23, then sigma 2 sigma 3. Then we have r13 sigma 1 sigma 3 minus b12.3 r23 sigma 2 sigma 3 and minus b13.2 r not r sigma 3 square. Okay, so now look at this equation properly. Look at these three equations properly. Okay, we have to eliminate these coefficients. These b12.3 we have to eliminate them, and then we have to eliminate all these b13.2. Okay, and represent them in the form of a determinant. Okay, so let us eliminate them. Let us represent them in the form of determinant as follows. So we have the first row having only x1, x2, x3. Okay, that is from equation 1. And then from equation 5, you will have for the first equation here r12 sigma 1 sigma 2, then sigma 2 square, then you have r23 sigma 2 sigma 3, then you have r13 sigma 1 sigma 3, and then you have r23 sigma 2 sigma 3, and finally you have sigma 3 square. So this will be your determinant, and this is equal to 0. So now we are going to perform some operations on this determinant. We are going to perform column operations. Okay, so for the first column 1, we are going to divide this first column 1 by sigma 1. Okay, similarly we are going to divide the column 2 by sigma 2, and we are going to divide column 3 by sigma 3. So if we perform these three column operations on this determinant above, what will we have? We will have x1 by sigma 1. We will have x1 by sigma 1, x2 by sigma 2, x3 by sigma 3, and then here we'll have r12 sigma 2, and then sigma 2, and then r23 sigma 2, and then r13 sigma 3, and then r23 sigma 3, and then sigma 3. Okay, so we will have this determinant, and it's going to be equal to 0. Now we are going to perform row operations. After performing those column operations, we have this determinant. Now we are going to perform row operations. Okay, so but here we are going to perform only on second row and third row. So the second row we are going to divide it by sigma 2. Okay, and then the third row we are going to divide it by sigma 3. Okay, so let us perform these two row operations on this above the determinant. What will we have? Okay, we will have x1 by sigma 1, x2 by sigma 2, x3 by sigma 3. So this first row will remain the same, and second row will be r12 1, r23. Third row will be r13, r23 1. Okay, this is equal to 0. So now let us expand this determinant using the first row. Okay, let us expand this. So we will have x1 by sigma 1, x1 by sigma 1 into 1 r23 r23 1 minus x2 by sigma 2 x2 by sigma 2 into 1 r12 r23 r13 and then 1, and then plus x3 by sigma 3 into r12 1 r13 r23. Okay, and this is equal to 0. And if you denote each of these determinants by omega 1, omega 11, omega 12, and omega 13, you will have x1 by sigma 1 omega 11 minus x2 by sigma 2 omega 12 plus x3 by sigma 3 omega 13 equal to 0. Okay, you keep this as equation 6. This will be your plane of regression expressed in terms of determinants. Okay, so first, in order to define this omega 11 and all, we just define a common matrix, a common determinant of correlation 1 r12 r13 and then r21 1 r23 and then r31 r32 and 1. Remember that r12 and r21 is the same, r13 and r23 is the same, okay, and so on, where omega ij, okay, is the cofactor. I think you already know what are cofactor minus, okay. So it is the cofactor of the ith row and the jth column and so on. And then from here you can easily find what is omega 11, what is omega 12, what is omega 13. Omega 11 is just the first cut off the first column, first row, and this will be your omega 11. Okay, omega 12 omega 12 will be first row, second column, okay, and so on. So now equation 5, go back again to equation 5, and you will have an expression for x1. Okay, x1 can be expressed as minus sigma 1 by omega 11 into x2 by sigma 2 omega 12 plus x3 by sigma 3 by omega 11. Okay, and therefore x1 is equal to minus sigma 1 by sigma 2 omega 12 by omega 11 x2, and then minus sigma 1 by sigma 3 omega 1 3 by omega 1 1. Okay, here it's omega 1 3, sorry. So this is your equation of the plane of regression of x1 on x2 and x3. So if you compare this equation 7 and equation 1, you can obtain an estimate of the b12.3 and b13.2. Okay, an estimate of b12.3 will be minus sigma 1 by sigma 2 omega 1 2 divided by omega 1 1, and an estimate of b13.2 will be minus sigma 1 by sigma 3 omega 1 3 by omega 1 1. Okay, so this is how we obtain the correlation, the equation of the plane of regression. Okay, and you can try by yourself for the general case. Okay, you can try by yourself, it's not hard at all. You can try, and in the same way you approach, you find the equation of the plane of regression of x1 on x2, x3, and so on up to xn. Okay, just approach in the same way, and then you can easily find.